Hello and welcome to episode 7 in my how-to series. Today we're going to take a look at FDM 3D printing. This video is mainly aimed at those looking to get started in 3D printing and don't know what to expect. With the recent development of resin 3D printers getting bigger, better and cheaper, many are questioning what's the point of the earlier FDM 3D printers? Well, hopefully this video will show you some of their strengths and how they can be a really useful tool for any maker. FDM printing is the process of creating a three-dimensional object in layers, from a reel of plastic filament which is heated and forced through a nozzle to create a finished subject. FDM printers have really taken off in the past 20 years, and manufacturers have come and gone. Broadly speaking, FDM printers fall into two main categories, enclosed and unenclosed. Having an enclosed printer has its advantages, as it allows you to print plastics such as ABS, which require a warm, stable environment. FDM printers can effectively be any size, and the stripped-down look of the unenclosed printers shows this clearly. They allow much larger prints to be created and are often cheaper than the enclosed printers. Of course, it's perfectly possible to build your own enclosure, so you can print plastic like ABS, but more on that later. Now you've seen some glamour shots of printers, let's get on with some printing. This is my printer, an Ultimaker 2, which I've had since 2014 and has been maintained and upgraded ever since. This is what I'll be using in this video. It's a great printer, well built and reliable. But what are we going to print with it? Well, the two primary types of plastic used for FDM printing are PLA and ABS, and we'll be printing with both in this video. This is how they normally come, boxed and sealed with printer settings clearly labelled on the outside of the box. PLA, or polylactic acid, is an organic plastic, which is cheap and easy to print. If you stick to the right settings, you should get good reliable prints. The only downside is that prints can distort if left in a hot environment. It's a great plastic to learn with and create high quality prints. The second plastic we're going to use is acrylonitrile butadiene styrene, also known as ABS. This plastic is very commonly used in daily items, even in Lego bricks. It's tough, relatively cheap, and will produce long-lasting, durable prints. It can be difficult to print and requires an enclosed printer with a heated build plate for best results. Once unpacked, the reels of filament are best kept stored in sealed plastic bags. This prevents any dirt and dust contamination, as well as keeping any moisture out. One crucially important point is to always make sure the end of the filament is well secured. If it comes loose and gets tangled up, when you come to print, your printer may jam and your print will fail. Once tangled, the filament is almost impossible to untangle completely. And this is where the filament lives on the back of the printer. It's drawn off the reel by a geared motor, known as an extruder. This is present on all FDM printers. The extruder feeds the filament up a tube to the print head. Also known as the hot end, here the filament is heated and forced out of the print nozzle onto the build plate while being moved along two axes. Like many FDM printers, this Ultimaker has an interchangeable nozzle. Ranging from 0.25 to 0.8mm, this allows you to print small detailed parts or larger parts efficiently. The nozzles are marked with their sizes and just screw into the print head. In this video, I'll be using the 0.6mm nozzle for all my printing. To load the files onto the printer, they're transferred via an SD card. This means the printer can stand alone from any computer and can be left to run a print job independently. But first of all, we need to prepare our 3D model for 3D printing, and to do this we need to use Slicer software. When you buy a 3D printer, you'll be able to download Slicer software from the company's website, or you can use a variety of other slicers that are available. I use Cura, which although designed for the Ultimaker printers, will also work with many other machines. It's open source, is regularly updated, and has many add-ons to make the 3D printing experience as painless as possible. The Slicer software needs files which are either in STL or OBJ format, so 3D models have to be created and saved in these formats. Here's a design I quickly created in my 3D modelling software to show you what can go wrong when designers don't carefully debug their models before making them available. I designed one side of this spaceship and then just mirrored it to create the other side. In the Slicer software, you can see the red tells us that something isn't right. When we get the software to cut the model into layers for printing, we can see one of the holes in the middle has disappeared, and there are lots of gaps in the layers. The two sides of the model are printing completely differently. This would be a disaster to print and would just fall apart. The reason for this is due to normals, an issue we looked at in the previous how-to video when we looked at designing parts for 3D printing. The mirrored part of the side that won't print is effectively inside out. We need to flip the normals to correct this. With that done, we can now resave the model and load it back into the slicer to check again. And with that fixed, we can now begin to prepare our model for 3D printing. In any slicer software, there are a whole host of settings you can change to get your perfect print, but right now we'll just look at the basics. It does look pretty scary, but most of these you don't need to worry about. So, what are we going to print? Well, there are plenty of sites online where you can download free 3D models, and this is the one I chose. This rendered image has the texture applied to it, but we just want the base OBJ file. It's on Free3D, and there's a link to it in the description where you can download it. I've loaded it into my CAD software to take a better look at it. It looks well sculpted and a good representation of a human skull. The proportions are good and it has enough detail. It's described as low poly, which means it's of low resolution to keep the file size down. We'll see more about that later, but I think it'll be fine. The lower jaw and teeth are separate parts, but I've combined them and added a couple of blocks to join the jaw to the skull, as I want to print this in one piece. Before we load this model into the slicer, we need to understand a few key settings. Firstly, layer height. This is the thickness of each individual printed layer. Thinner layers give smoother prints, which take less time to clean up, but take longer to print. Thicker layers mean quicker prints, but more time spent with the sandpaper. Here you can also set the print speed, but don't get carried away here, as it can affect the print quality. Going crazy fast can also do damage to your printer, so start slow and steady. You can speed it up later. Next, wall thickness and infill. You need to set the wall thickness as a multiple of the nozzle size you're using, and adjust the level of infill depending on how heavy and strong you want your print to be. Remember, thicker walls and more infill means more filament and a longer time to print. I'll be going for 2.4mm wall thickness and 20% infill. It's likely your print will need support structure to cope with overhangs. This is generated automatically and can be tweaked, but you should adjust the orientation of your model to keep this to a minimum. Supports are broken away from the final print, but do leave marks behind which are hard to remove. And finally, build plate adhesion. You need to give your print the best chance of sticking to the build plate, and the brim and raft settings can help with that. They are sacrificial, but far better than having a print come off the build plate after 24 hours of printing. Okay, let's see how I've set the skull up in the slicer. As the skull is so irregular, I've added a raft to anchor it to the build plate. I've set up the supports so they're only the ones touching the build plate, so there won't be any in the nose or eyes. I've tried to angle the skull so there should be no need for supports here anyway. Hopefully the support structure is in places where it shouldn't be too hard to clean up afterwards. Using a 0.6mm nozzle and a layer height of 0.1mm, the wall thickness is set to 2.4mm and the infill is 20%. The final layers of the print can sometimes cause problems due to the build-up of heat as the layers get smaller. Setting the minimum layer time to 15 seconds and using cooling fans can help with this. Having the print finish on the forehead should again make cleaning up fairly easy. In the bottom right hand side of the screen, you'll notice the estimate print time and the material usage. This print should take about a day to print and use about 114 grams of filament. This estimation of filament is really useful, as it allows us to judge whether we have enough filament left on our roll and whether or not we need to change it. With the file saved to the computer and the SD card, we need to do a little prep on the printer. To help the print stick to the print bed, I use a glue stick. There are other options, but I found this works best for me. It's cheap, easy to apply, and easy to remove from the print bed and the print. What's not to love? The glue stick is applied liberally to the print bed, and then we're good to go. With the SD card loaded into the printer, the file is selected and the printer set to run. This first print is in pink PLA. You can see the printer starting to lay down the first layer of the raft. So far, it looks like it's bonding well onto the build plate, which is a good sign. This is actual speed. I know it's pretty slow, but once the first couple of layers are down, we can speed it up. We also need to check some of the printer settings. The nozzle temperature is important to make sure the filament flows well. It's always best to refer to the supplier specification and start from the middle of their suggested range, and work from there. Flow rate is important, as it affects how much filament comes out the nozzle. Too low and the layers won't bond well together, and you will get weak layers. The final print may split apart. Too high, and the print will be messy, giving you a lot of work to do post-processing. Finally, we can increase print speed. This is best done in small increments, keeping an eye on print quality and the behaviour of the printer. High print speeds can produce really bad prints and potentially damage your machine, so take it easy here. These settings are easily adjusted on the fly, so just remember to keep an eye on your print and adjust accordingly in small steps. That way you won't get any nasty surprises and you should get a decent print. With everything running, these are the settings I use for PLA for this print. About halfway through the print, you can see the progress we're making. The support structure is looking good, and the main parts of the print are coming out well. There are a few wispy bits to the supports and infill, caused by too high a flow rate, but I'd rather have a smoother print, and they either won't show or they'll come away with the supports. And here's the finished print. Again, you can see the over-extruded wispy bits, but only on the supports. The surface finish is really good. I'm very happy with how this has come out. Next, we're going to have a go at printing the same skull in ABS, but to do this we need an enclosure to keep the temperature stable. This is my enclosure, homemade from plywood and acrylic. It fits neatly over the printer without fouling any of the moving parts. It's easy to remove when I need to, and it's a lot better than the cardboard box I used to have. Being able to see how the print is going is very important, in case of print failures or the need for any minor adjustments. And here are my settings for ABS. I'm using material called ABS-X, which is designed to minimise warping. There are lots of different types of filament out there, so choose carefully to suit your printing needs. Unfortunately, things don't always go to plan, and in this case one of the supports failed, which prevented the lower jaw from printing. This was irretrievable, so I stopped the print. This had printed fine in PLA, it was just down to the nature of the ABS. The rest of the print was really strong, it was just this one area that was the problem. There are a lot of things that can go wrong with 3D printing, and there's a handy guide online to help you troubleshoot your way to better prints. I've put a link in the description. My solution to this problem was to add supporting blocks in the 3D modelling software, but there are plugins available for Cura which would have allowed me to create my own custom supports in the slicer. A few hours into the print and I could see that my solution had worked, and I was past the point where the print had previously failed. And here it is, fresh from the printer. The supports look pretty ugly, but that doesn't matter, they're all coming off eventually. The finish everywhere else is fine, this should clean up really well. Resin printers are developing at an alarming rate, but few can economically print large items. This is down to build volume. This is the maximum dimensions of the space that a printer can print in, and it governs how big an object it can print. The main advantage of an FDM printer over a resin printer is the size it can print, and this got me thinking, how big a skull can I print on my printer? After a bit of experimenting in the slicer, I worked out that I could print a skull twice the original size. It was a real squeeze to fit it onto the build plate, the only downside being it was going to take nearly 5 days to print. It just had to be done, didn't it? So with the file on the SD card, I fired up the printer for a 5-day PLA workout. All looked good after the first day. The supports had printed well and I'd increased the speed without any issues. Extrusion was a little high, but the important surface finish was looking good. The following day and we'd got through the detail, but as the nozzle passed over certain parts of the print bed would shake, and this created a rough outer surface in some areas of the print. I backed off the print speed and the problem was solved. Finally, after 4 days of printing, this was the result, a near life-size skull. I'm delighted with the result. The surface finish is really good. The layer lines are visible, but that's not an issue for me. You may notice the checkerboard effect on the surface. This is due to the low poly nature of the original model. It's something I really like, as it adds another layer of pattern to the surface of the print. Now we can move on to the next stage, post-processing. We'll start with the small ABS skull and begin by removing the supports. I'm going to use my Dremel to cut out the blocks I added to the lower jaw, as I don't want to damage the main print. With these cut through, I can use pliers to remove the rest of the support structure. Some of this just comes out by hand, but pliers and cutters are the most effective tools. Now we just have to clean up the support interface and remove any unsightly layer lines. I use a variety of tools for this: sandpaper, files, cutters and scalpels. My most useful tool is my scalpel with a number 15 blade. This short rigid blade allows me to scrape down the surface in the most hard to reach areas on the print. Then file and sand out as many of the lines as you can. You'll be surprised how quickly you can get a decent finish by hand. Areas that need filling get a touch of this air drying car body filler. It's great for small imperfections and dries really quickly. There are several options when it comes to removing layer lines. Whatever product you go for, start by printing with a small layer height to give yourself the best chance of getting a good finish. XTC 3D is an epoxy coating which when brushed on forms a thick, even coat. It's a good product, but you must shake both bottles well and measure and mix carefully to get the best results. I used it in my T80 and Bluebird builds, with varying success. Currently a popular method for smoothing is 3D printer resin. It's a little hard to control, but it does give a thick hard surface depending on which resin you use. To get rid of small scratches, primer filler is very effective. It can be built up in layers and sanded to a smooth finish. With the ABS skull sanded smooth and a few small areas filled, I added some joins to the skull bones just by scribing in a zigzag pattern to the surface. ABS is an easy material to get a good finish with, and I prefer it to PLA. If you can overcome the printing issues, I highly recommend it. Now I've got a finish I'm happy with, it's time to give it a coat of primer. I'm going to use filler primer and begin by spraying the underside. Once that's dried, I just flip it over and spray the rest of the skull. The filler primer is very forgiving and goes on really well. Once it was fully dried, I moved on to the painting. Here I used a combination of colours, built up in mottled layers and sprayed with an airbrush. I then used artist's oils to add washes in the joins and areas of deep shadow. Highlights were dry brushed, and the teeth were picked out with acrylics and given a coat of gloss varnish. I think considering it was 3D printed on an FDM printer, the result's pretty good. Now let's move on to the big PLA skull. I knew PLA could be brittle, so where the supports met thin areas of the print, I decided to minimise any damage by using my Dremel. With that cut away, I could then use my pliers to break away the rest of the support structure. This is great fun, but you have to be careful not to get carried away and damage the print. Getting through the raft at the bottom was a bit difficult, but once I had an opening, I could easily chip away at the support. Where the support was short at the back of the skull, it was quite difficult to remove with the pliers, but I knew a coarse file would take it down in no time. And before long, it was all gone, and I could see the skull in its entirety. Now I just had to clean up to an acceptable standard where the supports had been, and decide on a finish. And here it is, all cleaned up, using a variety of tools, but mainly my trusty number 15 scalpel. I really just worked on the underside, sanding and scraping the surface, before buffing with fine wire wool. Any dust or remnants of wire wool were blasted off with an airline. The painted ABS skull was now not obviously a 3D print, and I wanted to go down a different route with this skull. I really liked the low poly pattern on the surface, and sanding out the layer lines would get rid of this. The layer lines were pretty fine, so I decided not to go for a painted finish, but instead multiple coats of clear lacquer. I sprayed the skull with a rattle can, exactly as I had with the ABS skull. This time the lacquer was built up in multiple layers, until I had a finish I was happy with. It took quite a while, but eventually I got there. And this is the end result. It's like a giant boiled sweet, and has a great gloss finish. I could have gone further with more coats, which would have pretty much hidden the layer lines. But I really like the low poly look, and it just shows that you don't have to remove every bit of evidence that shows it's a 3D print to make something that you can really be proud of. I may one day give it a few more coats and see how far I can take it, but right now I'm delighted with the result. So what's the verdict? Is FDM printing a thing of the past? Well, I'd say most definitely not. It provides a really good entry point for anyone wanting to start learning about 3D printing. It's relatively cheap to get into, and the filament's fairly inexpensive. With patience, you can get quite acceptable results. Okay, post-processing can be a bit of a pain, but there are options for that. But the big advantage FDM printing has over resin printing is the build volume. FDM printers are easily scalable by the manufacturers to allow you to print massive prints. Just take a look at some of the 3D printed builds on my channel to see what can be created with one of these machines. In the next how-to video, we'll take a look at the new kid on the block, resin 3D printers, the pros and cons, and how to get the best out of them. I hope you found this episode of my how-to series interesting. If you did, share with your friends, subscribe to my channel, and make sure you click on the bell icon so you get notified when the next video goes live. Don't forget to check out some of the other projects on my channel to discover more model making techniques. If you have any questions about issues raised in this series, just leave them in the comments and I'll get back to you. Thanks for watching.